Hey everyone, go on and open your book to page 160 and let's circle our verbs and underline the noun or noun phrase to which it corresponds. So today we're going to be applying congruence criteria to figures on the coordinate plane. And we're going to be proving the AAS criterion and develop the HL. I'm not going to tell you what this stands for right now, but we will be getting to it. Okay. Make sure you pause the video whenever you need to be working things out on your own. Okay, so this says on number 1, or we should be on page 160, reason quantitatively. Greg's boss hands him a piece of graph paper that shows the plans for a truss. Greg's boss asks him if he can prove triangle DBE is congruent to FCE. So DBE is congruent to FCE. So they're starting with the distance formula. So it looks like what we're going to be doing is just trying to find our distance and see if we can do this with SSS. Okay, so an easy one to start with right here is this distance. So I'm looking at the left side. So DE is 1, 2, 3, 4, 5. Okay, and then for the other ones, and again, we're not using a calculator right now. We'll talk about it. With colors here. We're going to find this distance from these distances. Okay, so 1, 2, 3, and then 1, 2, 3. Okay, and so you can actually use the distance formula. I generally count my distances and then use the Pythagorean theorem. So I would say 3 squared plus 3 squared equals c squared, which will be the long side. So 3 squared is 9 plus 9, which is c squared, 18, which is c squared. And then if I simplify this, remember it would basically be, take the square root here so we can see, it would be 2 times 9. And I chose 9 because that will break down, right? We can do the square root of that. So the square root of 9 would be 3. And then I'm left with the square root of 2. Okay? So BD is 3 square root of 2. Okay? So you're going to do the same thing to find this length over here. Okay? And then you're going to do it on the other side. So once you have those, I want you to think about if those were all the same distances or not. And it says, can Greg use this information to prove that these two triangles are congruent? Okay, so that is your job. I want you to pause the video and make sure you have an explanation. Remember, I'm taking a grade on this lesson that you're doing asynchronously. Okay, it says in item 5 of lesson 11.2, you discovered SSS, SAS, and ASA are not the only criteria for proving two triangles are congruent. You also discovered AAS as a congruence criterion. Okay, what does the AAS congruence criterion state? And it says mark the triangles below. So this is different ways we can mark this, but you can say, remember the angles, angle, angle, side. That's an example. Angle, angle, side. Okay, that's just an example of how we can mark them. There's other ways. Okay. Now we're on page 161. And this says the proof of AAS congruence criterion follows from the other congruence criteria. Complete the statements in the proof of the AAS congruence criterion below. So your job right now is I want you to look at the proof that you are seeing. Okay, this one right here. And I want you to fill in as much of this proof as you can by yourself. Okay, and I'm going to let you know, if I'm remembering correctly, that there is enough in here to prove angle, angle, side. But what we're going to do is prove it a different way. Okay, because they are giving us enough in here, because it's literally, I'm just going to show you on one triangle. We have N corresponding to Q, O corresponding to R, and then we have MO. So we have N, O, and then MO. So we have enough to prove it, but we're going through it and we're going to be proving it a different way. Okay, as a matter of fact, I will go on and let you know that we're going to prove this triangle through ASA. Okay, so I want you to pause the video before you go to the next one, and I want you to complete as much of this as possible.